right, let's talk about stretches and reflections for the parent function that is a quadratic. So consider f of x equals x squared. So this is a parabola, it's a quadratic, and it's called the parent function for this because it's the most basic function that all the other quadratics stem from. So it's the parent function for the quadratics. So let's look at a couple things. I'm going to take my lid off here. I'll be graphing these. Let's look first of all at this one. G of x equals negative x squared. So I'm comparing this with this. So it is a reflection and it's just reflected over the x-axis. So this right here, g of x equals negative x squared, is going to look just like this one, but it's going to be reflected over the x-axis. So it's just like we flipped it over the x-axis. So that's g of x. I'll call this g. I'll write g, standing for g of x. H of x equals x minus 2. The minus 2 in the parentheses there means that this function, the black one, is going to be shifted 2 places to the right. So it's going to be the same size and the same shape. I'm trying to draw this the same size and the same shape as the black one, but just shifted over 2 to the right because it's x minus 2. So if it's x minus 2, it's going to be to the right 2. If it's x plus 2, it's going to be to the left 2. So this one, being x plus 2, I'm going to take this and shift it there. So this one is shifted to the left 2, but same size, same shape as the black one. Now what's really different though is x squared plus 2, because that's going to be shifted up 2 units because we're just tacking on a 2 to the x squared function. So this was x squared and we're just saying plus 2. So we're just going to go up 2 here. Same size, same shape as the black one, but just shifted up 2. X squared minus 2 means we're going to come down here. Same size, same shape, but it just is shifted down 2 units for this one right here. So that's a bunch. Hopefully you see that. You might have to replay this to see what all's going on, but putting a negative in front of a function means it's going to be a reflection over the x-axis. Doing a minus 2 inside the parentheses is a shift to the right. Plus 2 is a shift to the left. Plus 2, not in the parentheses, but just tacked onto it is up 2. That's down 2 units. So consider this. Here it is again. F of x equals x squared, but now let's do this one. So there's several things going on here. Number one, it's reflected over the x-axis, so it's going to be going in the opposite direction. It's shifted to the right 2 and up 3. So let's do that first. So to the right 2 and up 3 means it's going to start there. So to the right 2, up 3, so to the right 2, up 3. So here is my vertex. But instead of drawing it this way, because of the negative, I'm going to turn it upside down. So same size, hopefully I'm freehanding it here. Same shape, but reflected over, going in the other direction and to the right 2 and up 3. Well, that's a little bit about stretches and reflections. Now, one thing I didn't do, hang on just a second, let me tear off another page. One thing I didn't do is I didn't include any stretches on that. So in the previous one, we had reflections and we had horizontal shifts and we had vertical shifts and we had reflections, but we didn't have stretches. So consider f of x equals x squared. This is what a stretch looks like when we have this. So we have 4x squared. So when you have a number that's in front of the function, like a number like 4, then that's going to be a stretch. And it's as if we grabbed this and we stretched it up. So this is a vertical stretch by a factor of 4. So what would happen is this would be thinner. It's going to be thinner. And that's called a vertical stretch. So that's for this one right here. Now, if you have a negative, we know it's going in the other direction, so it's a reflection, but the fact that it's a fraction between 0 and 1 means that it's going to be thicker. In other words, it's going to be like this. Now that should have hit the origin there, so I'm freehanding this. So it's going to be thicker. So the 1/4 means it's thicker, it's wider, and the negative means that it's reflected over the x-axis. So we took the black function, this one, we reflected it over the x-axis, and it's not a vertical stretch, but a vertical compression. So it's as if we vertically compressed it or pushed it down. If you were to push down this black function here, if you push that down and it was rubberized, then it would go wider. So that's called a vertical compression. So a vertical compression. So this blue one down here is this one here. Anyway, there's more to be said from that. I have some more videos on the channel, so look around, look for stretches and reflections and shifts and anything that has to do with parent functions and that sort of thing. See if you can find some other explanations.